When we look at a door, we should not look at it as a rectangular wooden piece. If that was true, we will not be able to open it. We must look at it as a rotating object, which is rotating about a fixed axis hinged at one of its sides. For entering a room, we first have to rotate the doorknob, and then you either push the door or pull it depending on the type of the hinge. If you remember what we learnt in kinematics, the word push or pull represents force. We are applying the force on the handle of the door in order to rotate the door, but in this case, the force alone is not responsible for this rotation. There is something else in action here. It is the distance from the axis to the point at which we apply the force. This combination is known as torque. As push or pull denotes force, twisting creates torque, which is rotational equivalent of force. Torque causes rotational motion of that object about one or more axes that pass through its center of mass. It is denoted by the Greek symbol tau. Mathematically, torque about a point is defined as the vector product of position vector and the force. Torque is a vector which is perpendicular to both the position vector and the force vector. As a result, the torque of a vector perpendicular to the plane defined by position vector and force. The direction of torque is given by the right hand thumb rule. To apply the right hand rule, put the fingers of right hand along the position vector and bend them towards force vector. The direction of thumb will give the direction of torque. Let's take an example to understand this concept better. Question: a uniform wooden stick of mass 1.6 kg and length L rests in an inclined manner on a smooth, vertical wall of height h greater than L, such that a small portion of the stick extends beyond the wall. The reaction force of the wall on the stick is perpendicular to the stick. The stick makes an angle of 30 degrees with the wall and the bottom of the stick is on a rough floor. The reaction of the wall on the stick is equal in magnitude to reaction of floor on the stick. The ratio H by L and the frictional force F at the bottom of the stick are: acceleration due to gravity is equal to 10 meters per second square. The options are: this question was asked in JEE Advanced 2016 exam. Solution: we are given a stick of mass equal to 1.6 kg. The reaction force of the wall on stick is equal in magnitude to the reaction force on floor. Frictional force F is acting at the bottom of the stick. Weight mg is acting downwards. If the angle between the stick and the wall is 30 degrees, then the angle will also be 30 degrees. Now, vertical component of reaction force N sine 30 degree will act in y-axis and horizontal component N cos 30 degrees will be in minus x-axis. By vertical equilibrium, N plus N sine 30 degree equal to mg. This implies normal reaction equal to 2 mg by 3. By horizontal equilibrium, frictional force equal to N cos 30 degree. This implies frictional force equal to 2 mg by 3 into root 3 by 2. On substituting the value of mass and gravity, we get frictional force equal to 16 root 3 by 3 Newton. Since rod is in equilibrium, therefore net torque about A is 0. Writing torque about A, we get mg into L by 2 cos 60 degree equal to normal force into h by cos 30 degree. H by cos 30 is the distance from A to the normal force on the stick. On substituting the values of a normal force and cos 30, we get ratio H by L equal to 3 root 3 by 16. Hence, option D is correct.
Please like, share and